And this is for 6.2. 6.2, we have applications of the normal distribution. Applications of the normal distribution, the word applications, meaning that we have it for word problems. So we have word problems involved with the normal distribution. We're going to use this formula here to transform into a normal variable. So z equals to x minus mu divided by sigma, where x represents for the individual value, mu is for the population mean or population average, and sigma is for population standard deviation. When we do our computation for z, we're going to round our computation to z to 2 decimal places. The reason why we're rounding it to 2 decimal places, so we can read the results from the normal distribution table. As you already know from section 6.1, in order for us to read from the normal distribution table, our z value would be in terms of 2 decimal places. However, the result is in terms of 4 decimal places here, okay? So what it's telling us on the note here that round the intermediate z value calculations to 2 decimal places, and the final answer as a decimal to 4 decimal places, all right? So now in this lesson, I'm going to show you how to do it 2 ways. One is by solving for z and reading the result from the normal distribution table. Another way is by using the normal CDF function from your calculator. So I will show you how to do both ways. Now on your assignments on ALEKS, if it tells you to use a graphing calculator, then just follow my method on how to do on a graphing calculator. If it tells you on using the standard normal distribution table, then you just use the table to solve. So there are 2 ways to solve for applications of the normal distribution, which we're going to go over in the lesson here. All right, so let's take a look at what we have in example 1. The national average SAT score is 1019. If we assume a normal distribution with sigma equals to 90, what is the probability that a randomly selected score exceeds 1200? Now I'm going to show you how to analyze the word problem here. So to analyze the word problem, you might want to break it down into 1 sentence at a time and look for keywords in each sentence. So from the first sentence, the national average, so the key word here is the word average. This tells us we have the population average, which we stated in our formula earlier. Population mean or population average, we have the notation of mu. So mu equals to 1019, all right? If we assume a normal distribution, now, because we're doing it lesson by lesson, so you probably don't see the importance of the keyword here, but when you take the quiz or an exam, this will narrow down for us that we have a z. So we're going to use our formula for z to solve. With sigma equals to 90, look like a letter O, and sigma is for the population standard deviation. What is the probability that a randomly selected score exceeds? So with exceed meaning that is greater than. So we are looking for the probability that a randomly score is greater than 1200. So we're going to write probability of x is greater than 1200. All right, so that's how we analyze the problem. We have mu equals to 1019. We have sigma equals to 90, and we're looking for the probability of x is greater than 1200. We now have these 3 quantities to replace in our formula for z to solve. Z equals to x minus mu divided by sigma. Knowing that x is 1200 minus mu of 1019, we'll find the difference and we're dividing it by 90. All right, I'm going to share my calculator to show you the computation. A couple ways to go about it. One way you can do this we'll take 1,200 minus 1,019. Press enter to find the difference on the numerator. Then take the result of 181 divided by the denominator of 90 to get to 2.011. Now I'm going to show you another way, but before I show you another way, I'm going to show you a computation there. 1,200 minus 1,019 divided by 90. What happened if we key in this way? If we key in this way, our calculator would perform the division first. So it would take 1,019 divided by 90, then take 1,200 minus the result. And watch what happened when we press enter. We're not going to get the 2.011. But if you want to do the whole thing, I'm going to show you to do this way here. Open parentheses, 1,200 minus 1,019, close it, hit the division sign, divided by 90. If we key in this way, we tell our calculator to do the subtraction, then take the result divided by 90, which is exactly what we did first up here, okay? So this way will give you the same results as what we did from the beginning. But this way in the middle here, this is not what we intended to do. So therefore, if you want to do the whole computation all at once, then make sure you key in with parentheses. All right, so here we get 2.011. Now, what did we say here? Round the intermediate z-value calculation to 2 decimal places. So now I'm going to take 2.011. I'm going to underline the second digit, which is this one right here. We're going to look at the digits to the right. Because the digit to the right is less than 5, we're going to keep the underlying digits as is. So we'll round to 2.01. Okay, we're starting out our probability in terms of x. We now can transform to a normal variable. So probability of x is greater than 1,200. We now can write it in terms of z. And notice that here in x, we have a greater than because the word exceeds. Then when you translate it to z, you would use the same inequality of greater than. Now for x equal to 1,200, corresponding to z of 2.01. Isn't it? We already know how to find the solution for a problem like this. We sure did. We know how to find it from section 6.1. We draw our curve, mark 0 in the middle. Our z is positive 2.01. We're going to mark it to the right of 0 because positive meaning to the right. Now, what region are we interested in? We're interested in greater than. You see the arrow is pointing to the right, meaning the shading should take place to the right of z equal to 2.01 as well. Okay, then what we're going to do, we're going to read it from our normal distribution table. How to read it from our table for z equal to 2.01. We go down to 2.0. When we go down up to the first digit after the decimal point. Then we move it over by 0.0 and whatever the digits of the hundredths place value. Okay. So then now, first of all, z is positive. So we're going to turn it to the page where we see for positive z value. We're going to locate 2.01. So what we're going to do here, we go down to 2.0 and we move it over by 0.01, which is this one here. So we map it down, we get 0.9778. Okay, then that gives us the area to the left of z equals to 2.01. So remember what we learned from 6.1. The area that we get from our table, and we see at the bottom of the table as well, the area that we get from our table gives us the areas to the left. And what we want the area to the right. And what we learned from 6.1 from the procedure table. To find the area to the right equal to area equal to 1 minus the area from the table. So therefore, I'm going to write it as a reminder for you here. Right equals to 1 minus the area from the table, which means we're going to take 1 minus 0.9778. We ended up with 0.0222. So this is how we solve for a normal distribution problem using a standard normal distribution table. Another way to solve for this type of problem is by using a graphing calculator. So with the same problem, let me take you to the calculator page. So you're going to turn it to a couple pages until you see the direction for calculator direction for TI 83 or 84 plus. So the first thing we need to do is to make sure our calculator is in the correct mode, and the correct mode with these directions here would be the one for stat wizard off, okay? So how do we do that? To verify that, what you're going to do, you go to mode, which is on the second column of your calculator. You go to mode, then you go down to, you can go down to until you see stat wizards here, okay? Then make sure that you have it on the off that's being selected here, okay? Then that means the calculator is in the correct mode. Okay, then we're going to go on to work on our problem here. So now, our problem, we have it for greater than 1200, meaning that we're going to follow by this case right here. How to compute for greater than an x value. The direction tells us second bars, then select normal CDF, and we're going to key in this order here, okay? So let me take you to the problem. All right, so example 4 is the direction on how the direction will tell us in the problem on using a TI 83 or 84 plus with the same problem, okay? So we know that in the problem, we know that the average is 1019. So this example 4 is the same as what we did in example 1. So 1019 from you, we have sigma equals to 90, and we have our x exceeds 1200, meaning that x is greater than 12, probability of x is greater than 1200. All right, so then now, on our calculator, what we're going to do, I'm going to key in to show you. Second, and then you have the word bars on the fourth column of your calculator. You're going to go down to select number 2 on normal CDF, okay? So let me write down the direction here. So what you should have is normal CDF. And to get to the function of normal CDF, you do second bar to select number 2. And the order it goes is that x, comma, E99, we have mu and then sigma, which is for our problem, it would be a normal CDF. I have it here, but I'm going to rewrite it for you. So x is 1200, comma, how to do E99? I'm going to show you how to get E99 in a minute. We have mu of 1019 and sigma of 90. We'll close it and then we'll press enter, okay? All right, so now we do have the normal CDF command function. We're going to select enter. So when you select enter, then that means you are ready to enter in your quantities here. So what we see that we have 1200, comma. The comma key, let me move up my calculator so you can see more of it. The comma key is right above number 7, okay? So that is 1200, comma. Now, E99, how to get E99? You do the second key and then you do the comma key, this will give you E. Why? Because E is in blue here. That's why you have to hit the second before you do the comma. How to do 99? You just key in the digits 9 2 times, and that will give you E99. Now we're going to press comma again, and we're going to key in the rest of the values. 1019, comma, and with 90, and we're going to press close parentheses. Press enter. Okay, from our result here, we see from our calculator 0.022156 and so on. We're going to round the final answers to 4 decimal places. We underline the fourth digits, which is a 1. We look at the digits to the right is a 5 here. So we're going to round it up to 0.0222. And if we compare this result with what we get from our first example, because it's the same problem, what result do we get from the table? The exact same result, okay? Now, sometimes with our calculation, in terms of computing for Z and use the normal distribution table to find the result, compare with what we have on our graphing calculator, sometimes the results are off a teeny bit. And the reason why it's off a teeny bit is that due to the fact that we round Z to 2 decimal places here, okay? Well, we have to round to 2 decimal places in order for us to read it from the normal distribution table. So meaning that in terms of the two calculations, which one is more accurate? The one that is by using the graphing calculator would be more accurate. Now, if we are doing it by, your phone app, then it will go the same thing. And how you would do by the phone app here? Let me go to my phone app, then I'll show you. So for your phone app, your phone app, the mode is already in start with the off, so you don't have to worry about if you go to mode, you don't have to worry about it. Okay, so just use the app directly. All right, I'm gonna get out of that mode. I'm gonna show you how to get to normal CDF here. Same goes. Second bars, okay? You're going to select number 2 from the drop-down menu here. You're going to key in for the case of greater than for this problem, 1200, comma. How to do E? Second, comma. That gives you E. You key in 99. Next, comma, 1019, comma, and sigma is 90. Close it. Once you close it, press enter. Then you will get the same result as what you will get from a graphing calculator because it's just the mirror image of it. Okay, so we are done with one case in terms of greater than. So remember, we always have 3 cases. One of the cases would be greater than, another case is less than, and then the other case would be for between. Okay. All right, so example 1, tied in with example 4 on graphing calculator, same problem. For second example, what we have in second example, the average salary for first-year teachers is $27,989. If the distribution is approximately normal, with sigma equals to $3,250, what is the probability that a randomly selected first-year teacher makes these salaries? And in part A, less than $20,000 a year. Part B, between $20,000 and $30,000 a year. I'm going to show you how to analyze the problem again. So from the first sentence, we see the keyword average. The average salary for first-year teacher is $27,989. This tells us we have the population average, which is mu. So mu equals to 27,989. All right. What we have on the next sentence, if the distribution is approximately normal, this narrow down to us that we're going to use a formula for Z to solve with sigma equals to $3,250. Here comes the question. What is the probability that a randomly selected first-year teacher makes less than $20,000 a year? So we're looking for the probability that X is less than, we're talking about an individual value here. What is the probability that a randomly selected first-year teacher? So this was first-year teacher, we're talking about an individual value. Therefore, we're looking for probability of X is less than 20,000. Okay, so just like the previous problem, we have our value for mu, we have our value for sigma, we have our value for X. We're going to use the Z formula to convert from the probability in terms of X to probability in terms of Z. So what we're going to do, we're going to take X of 20,000 minus mu of 27,989 divided by 3,250. So I'm going to do the computation all in one. So I'm going to use parentheses here. So open parentheses, 20,000 minus 27,989, close it, divided by 3,250. So what we're telling our calculator to do the subtraction and then the division. Okay, so here we have the values of negative 2.458. We're going to round Z to 2 decimal places in order to read it from our normal distribution table. We underline the second digit, which is a 5. We look at the digits to the right because we have an 8, is meaning that it's 5 or more. We're going to increase the underlying digits from 5 to 6. So now, what does this mean? It means that we started out with our probability in terms of X is less than 20,000. We now can write our probability in terms of Z. And because we have less than in terms of X, then in Z, we also use less than. For X equal to 20,000 corresponding to Z of negative 2.46. How do we find the solution for something like this? Just going back to our previous lesson in 6.1, we draw our curve, we mark 0 in the middle. Because the value is negative, we're going to mark it to the left of 0. And we're interested in the area that's less than negative 2.46. Therefore, the shading takes place to the left of negative 2.46. Then we go to our table, how to read it for Z equal to negative 2.46. As you already know, to read it from our table, we go down up to the first digits after the decimal point. Then we move it over by 0.0, and then whatever the digits of the hundredths place value. Okay. So on our table here, we're going to move down to negative 2.4, and we're going to move it over by 0.06. It's right here, which tells us what we have. We're going to map it here, everybody, and I'll bring it closer for you to see that we have 0.0069. That tells us the area to the left of 0.0069. Now, because we're also looking for the area to the left, so therefore, it is exactly what we get from the table. Because remember, what did we learn in section 6.1? To find the area to the left of any Z value, our Z value here is negative. But remember, Z can be negative or positive, but the area is always positive. Then we just look up the Z value from the table and use the area given, right? So meaning that left is directly from the table, equal to area from the table here. So therefore, we have this, all right? So now, I'm going to take you to, so this is how we solve for the problem using the than the normal distribution table. I'm going to take you to the calculator page again. So if you flip to a couple pages, you will see the calculator direction on how to do it for the case for less than. So let's take a look at what we have for less than, how to compute it for less than on a TI 83 or 84 plus calculator. We still go to second bars, and then we use this command set normal CDF, and we do the negative E99, comma X, comma mu, comma sigma. Now, I do wanted to get your attention on for the negative is right below number 3, not the same as the subtraction sign. So please use the negative below number 3. If you use the subtraction sign, you will not get the correct answer. So I wanted to make sure you know that. So negative E99, you do the negative key and then the second comma. That will give you E and then you key 99. All right, so let me take you to, and I made it with example 3. So let me take you to example 3, which is that example 2 using from the normal distribution table, the same problem here. All right, but the direction here tells us to use a TI 83 or 84 plus calculator. All right, so for the case of less than, we do normal. Let me write the command first, and then we apply to the number in our problem. Normal CDF, and we're going to do negative E99, negative E99. So for greater than, you do positive E99, and which you do the X value first before the E99, okay? Here you do the negative E99, you'll have the X, comma mu, comma sigma, which we apply to our problem, then I have it down here for you, okay? All right, so let me show you how to do on a graphing calculator again, and I'll mirror image with the phone app as well. All right, so we go to second, we go to vars, which is on the 4th column of our calculator here. We use our down arrow to go to normal CDF. All right, the first thing we needed for the case of less than is negative E99. So to get the negative, you're going to select this key here. E99, you do second, and then the comma key. As you know, the comma key is above number 7, and then you key in 99, all right? Then now, you see we have negative E99. We're going to do comma. What's next is our X value, which is 20,000. When you key in the number that has more than 3 digits, you don't use the comma to separate the period. Here we use the comma to separate from one quantity to another. So meaning that in 20,000, you just key in 20000. You don't do 20 and then comma 3 zeros, okay? Mu, we have 27,989, likewise, comma, sigma, we have 3,250. Close parentheses, press enter. All right, so what we see from our result here, 0.00698. And what we have, if we take this result here, we're rounding it to 3 decimal places. So think about it, 4 decimal places, my apology. 0.00698 with more decimal places, 1, 2, 3, 4. The 4th digit is a 9. We look at the digits to the right, we have a 5 or more here because we have an 8. Then we're supposed to increase the underlying digits by 1. But 9 is a special case, so we're going to increase the 1 before that. So meaning that for this result here, we're rounding it to 4 decimal places, meaning that we have 0.0070. Okay, so now earlier from our table, remember area to the left, we found that it was 0.0069, right? So like I said that due to rounding, our answers sometimes will the same problem, but by using the calculator, it's more accurate. So this one, so we compare the results with the table. The table is a little bit off, but it's perfectly fine. if you think about it, it's 0.0069 versus 0.007, very, very small, like 1 out of 10, 1 out of 1,000. Okay, all right. So let me get to the phone app, and I'll show you one more time on the phone app here. What we have, we're going to go to second bar. We go down to number 2 for normal CDF. We need the negative E99 for our problem first, and how to key in a negative. Negative this one here, second, comma, that give us E, then we do 99, comma, we have X of 20,000, comma, mu of 27,989, comma, 3,250 for value for sigma. Close the parentheses and press enter. Then you will get the same answer as what you get from the calculator. Okay. All right, so we have demonstrate another case here. So for this part example 3, part A, we did it in terms of our calculator for the case of less than. I'm going to come back to example 2 where I asked you to do by, we're going by the table. We're going to continue to solve for the problem. So for part B, it's between $20,000 and $30,000 a year. So meaning what we have here, we have two X values. All right, so we have X equal to 20,000 and X equals to 30,000. Well, I chose 20,000 to 30,000 because we did our computation for 20,000 here already. So for our Z, with the first Z value we get is negative 2.46. Now we're using the same value for mu and sigma, but we just change X to 30,000. So let's share this. Let me share my calculator to show the second computation for Z here. Open parentheses, 30,000 minus 27,989. Close it, divided by 3,250. Then this gives us 0.6187 and so on. But we're going to round Z to 2 decimal places. Why we're rounding it to 2 decimal places? Because in order for us to read it from our normal distribution table, Z has to be in terms of 2 decimal places. So 0.618, we underline the second digit, which is a 1. We look at the digit to the right, it's 5 or more, so we increase the 1 digit to 2. So we now have 0.62. All right, so let me rewrite the problem here. We're starting out with between X equals to 20,000 to 30,000. And how do we write our inequalities for between? Between, we write it like this, just like the notation you've seen for between from 6.1. Then now, you're going to write your probability in terms of V, okay? For X equal to 20,000, we have corresponding to V of 2.46. For X equal to 30,000, we have it corresponding to V equal to 0.62. And again, the way we do our inequalities would be the same. Well, the case for between, let's revisit what did we learn in 6.1 for between. And here we have one negative Z value and one positive Z value. So you're looking at this case right here. But between any two Z values, we look up both Z values and subtract the corresponding areas. So meaning what we have here, so what we have here, we're going to draw our curve. We're going to mark 0 in the middle. One Z value is negative 2.46. So here we have negative, we just go on to the left side of 0. The other Z value is positive 0.62. So 0.62 is close to 0 here. So I'll mark 0.62. What we are interested in, we're interested in the area between these two Z values. Okay, so then now, how do we read it from our table? Well, it doesn't matter which Z values we read it first, but since we did the reading from our table for the area that read is less than negative 2.46 from part A already, we know this is 0.0069. We're going to read it for positive 0.62. Let's do a quick review on how to read it from our table for Z equal to 0.62. We go down to 0.6 and we move it over by 0.02. Okay. Let me project the table to show you what we have for 0.62. So we go down to 0.6. This is what we see from our table. And 0.02 is 0.00, 0.01, 0.02, right? You can count this way, or you can look it up from here as well. So this tells us we have 0.7324. Let me bring the table closer. Okay. So here we get 0.7324. So we look up both the values already, and let me revisit the procedure table one more time. For between any two Z values, we look up both Z values and subtract the corresponding areas. Subtract the corresponding areas, meaning we take the larger area from the table minus the smaller area from the table. So here we have 0.7324. We're going to minus 0.069, which we ended up with 0.7255. And that's how we solve. So pretty much we cover all three cases. We did in example 1, we did it for greater than. Example 2 part A, we have it for less than. Example 2 part B, we have it for between. All right, then now I'm going to take you to the problem where the same problem where we're doing it with a graphing calculator. So now what we see here for between two x values, and here we still do our second bars to get the command of normal CDF. But notice, in less than you have negative E99, in greater than you have positive E99. Between two x values, you don't. You only have normal CDF, x1, comma, x2, comma, mu, comma, sigma. All right. So let me take you to example 2, part B, using a graphing calculator. The same example 3, the same as what we did in example 2 using the table. So now what we have for our command between, let me write it here first. You use the command of normal CDF, then you have x1, comma, which is your smaller x value, x2, comma, mu, and sigma. All right, then this I'm rewriting down here for you. Okay, so what you have is normal CDF, 20,000, comma, 30,000, comma, 27,989, comma, 3,250, close parentheses, and press enter. Let me do this on here for you. Second bars to get to this drop-down menu. Then we select number 2 from the drop-down menu. So you go down to select number 2, press enter. Here we're going to key in 20,000, comma, 30,000, comma, 27,989, and mu we have 27,989, sigma 3,250, close parentheses, press enter. So here we get the answer of 0.7249 and 249 and 8, okay, and more decimal places. Let's round the result to 4 decimal places, 1, 2, 3, 4. So we underline the 9 here. We look at the digits to the right is 5 or more. We increase the underlying digit. So because the underlying digit is a 9, we increase the one before that. So which means we round it to 0.725. We increase the 4 to a 5. And if you wanted to write it with 4 decimal places, you can fill in with a 0. So now what you see here from this result, from this result, we get 7,200, 0.725. It's a teeny bit off compared to our previous results that we ended up with 0.7255, okay? So by doing it with the normal distribution table, we ended up with 0.7255. Here, by doing it with our calculator, we have 0.725. So it matches up to 3 decimal places for this problem. And the fourth one is off by 5 out of 10,000. No, 5 out of 10,000. That's right, 5 out of 10,000. Very, very small. Okay, so that's what we have. So we demonstrated all 3 cases, less than, greater than, and between. Now I do have a practice problem. So let me turn the page to show you. So after example 2, find the normal distribution table. I have the practice problem for you here. Very much similar with what we worked on in the lesson. Let's take a look at what we have in the first sentence. The average age of CEO is 56 years. So from reading this problem, the first sentence, we have the keyword average. This tells us we have the population average, which is mu. So mu equals to 56. Assume the variable is normally distributed. So this gives away that we're going to use our formula for z. Okay? If the standard deviation is 4 years, so what we see here, standard deviation is 4 years. That tells us sigma equals to 4. What is the probability that the age of a randomly selected CEO will be in the range between? So we're looking for the probability that a randomly selected CEO age is between. And here we write the lower number is 53 and the bigger number is 59. This is what we are looking for. All right. So like I mentioned, how we do between? We do inequalities like this. Okay, so what we know from the problem, let me write it down over here so that way it's easier for us to look for the information. After we analyze the problem, we know mu is 56. We know sigma equal to 4. And we have x1 equal to 53, x2 equal to 59. We are ready to solve for z. So we're going to use x1 equals to 53 to solve for z. Solve for z. Z1, all right? So we can say that z1 equals to x1 minus mu over sigma, which we have x1 of 53 minus mu of 56 divided by sigma of 4. Okay, let's see what happened with our calculation for the first z value. Open parentheses, 53 minus 56, close it, divided by 4. Now, not every single z value you have to do the rounding. It's possible you have a terminating decimal. So when we press enter here, we get negative 0.75. This is our first z value. It terminates at exactly 2 decimal places, so we don't have to worry about rounding. Now, we do the same thing. Use x2 equals to 59 to solve for z. And I'm going to call this is z2, okay? Then what we have here, z2 equals to x2 minus mu over sigma. Knowing that x2 is 59 minus mu, which we have 56, divided by sigma, which we have is 4. Let's find out what we have here again for our second computation for z. Open parentheses, 59 minus 56, close it, and dividing it by 4, which we have a positive 0.75. Okay, so we started out with our probability in terms of x. we can write it in terms of Z to find our solution. So here it is. We mark 0 right in the middle. What we have is one Z value equal to positive 0.75. The other Z value equal to negative 0.75. We are interested in the area between these two Z values here, okay? And let me rewrite the problem. We started out with X goes from 53 to 59. We now can write the problem in terms of Z. For X equal to 53, corresponding to Z of negative 0.75, X equal to 59, corresponding to Z equal to 0.75. And we know we do our inequality this way for between. Okay, so let's read it from our table. The table gives us the area to the left, therefore, we're pointing it to our arrow to the left. We're gonna read it for the positive 0.75 first. We go down to 0.7 and we move it over by 0.05. So what this is telling us here is we have 0.7734 for the area to the left of V equal to 0.75. And let me bring it closer for you. Okay, so here we have 0.7734. We're going to turn our table to negative Z value, and we're doing the same thing. We go to negative 0.7, and we're going to move it over by 0.05. So 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5 would be this one. Or if you look it up from our 0.05, then you map it down would be the same, okay? So 0.2266, and let me bring it closer for you to read it from our table here. All right, so 0.2266, we reviewed it earlier for the case for between. Between from our table, from our procedure table, it tells us larger area from the table, and we're going to minus the smaller area from the table. So that tells us in our problem here, we would take 0.7734, it's the larger area. Let me get to black pen. 0.7734 minus 0.2266. And let's find out what we get for the result here. So 0.7734 minus 0.2266, which we get 0.5468. So 0.5468, if we wanted to do the interpretation of the result, it's best we put it in percent. So it means that 54.68% of the randomly selected CEO will be in the range between 53 to 59 years old. So that's the interpretation of our result. Okay, so here, this problem, again, we did it by using the standard normal distribution table, solving for Z and use the table. Then what we have here, turn it over to the practice problem. If you the same problem, but you see that it tells us to use a TI 83 or 84 plus calculator, and we're doing it for the case between. So we're going to do normal CDF. Between you have x1, comma, x2, comma, mu, and sigma, which means we apply to our problem, we would have normal CDF, x1 is 53, x2 is 59, mu is 56, and sigma is 4, okay? So that's what we're going to key in on our calculator here. Second bars, we go down to normal CDF. We're going to have 53, 59, 56, and 4. Close the parentheses. I'm hoping to get something close to 54%. And here's what we get. Point, so 0.54674 with more decimal places. We're going to round to 4 decimal places. So the fourth digit would be the 7. We'll look at the digits to the right. It's less than 5. We're going to keep the underlying digits as is. So here we have 54.67%. Earlier, we did it by our normal distribution table. And let me take you to that problem. And what we have here, 54.68%. So we off by 1 out of 10,000, very, very small. But again, if you follow the method that's indicated on your assignments, then you should not be off. But if you don't want to use a calculator, just to use the normal distribution to solve, and if you get marked down due to a teeny bit off, just let me know and I'll be happy to credit that for you. So you have the device, that's great. Or if you don't have a graphing calculator, please download the graphing calculator app to use it. So that is your job, because especially when we get to chapter 7, we're doing confidence interval. We would need the help from our graphing calculator to get the data summary. Okay. But again, if you like to do with just using the table, and if you get marked down because due to rounding, send me an email. I'll be happy to go into your account and give you back the credit. All right. So similarly, with what we have for this problem, I have a your turn to practice problem here. The average credit card debt for college seniors is $3,262. We see the keyword average. So we're going to say this would be our population average, which tells us mu equals 3,262. Again, with word problem, what I recommend you to do is to break it down into one sentence at a time, or in fact, even half of a sentence, and you come across your keyword, pause, analyze the problem. If the debt is normally distributed, that's tell us we have Z. Okay, we're going to use a Z formula to solve. With the standard deviation of 1,100. So standard deviation of 1,100. Here we have sigma 1,100. Here's what we're looking for. Find the probability that the senior owns at least 1,000. So let's talk about the language of at least 1,000. So meaning, is it 1,000 or more or less? So think about what we have here. So students often get the language of at least and at most mixed up. And we talk about the language of at least and at most in section 5.3. The way to remember at least is that I'm going to relate it to something that you already know here. At least 18 in order to vote, meaning that you have to be 18 or older. Or at least 21 in order to drink, meaning you have to be 21 or older in order to drink. So then this helps us to know which way it goes. At least 1,000, meaning 1,000 or more, okay? So we're looking for the probability of X is greater than 1,000. Okay, so we have a value for mu. Let me write the word solution here. After we analyze the problem, we have our value mu equal to 3,262. We have sigma equal to 1,100. We have X equal to 1,000. So we're looking for the probability of 1,000 or more. So again, we're going to solve for these because we only have one X value. So we don't need subscript of X1 and Z1, which is just write it like that. Z equal to X minus mu over sigma. Knowing X is 1,000, mu of 3,262 divided by sigma of 1,100. So this is 1,000, this is 1,100, okay? How to key in on our calculator, I'm going to do open parentheses, X of 1,000 minus 3,262. Close it, divide it by the sigma of 1,100. Press enter. Here is what we get, negative 2.056. With more decimal places, negative 2.056. We're going to round to 2 decimal places here. Underline the second digits. We look at the digits to the right, it's 5 or more because we have a 6 here. We're going to increase the underlying digits by 1, so we have negative 2.06. Okay, we started out with our problem in terms of x. We now can write our problem in terms of v. So our z value is negative 2.06. We're going to mark it to the left of 0. So remember, z can be negative or positive, but what we get from our table is always positive because the table gives us the area to the left. So area cannot be negative, okay? Z can be negative or positive, but area is always guaranteed to be positive. And the table gives us the area to the left. That's why arrow is pointing to left. So here we have probability of x is greater than 1,000. We translate it to z is greater than. We have the greater than inequality here. Then in z, we also use the same inequality. Greater than negative 2.06. Let's find out. So we go to our negative z table. We go to negative 2.0. This one here. And we're going to map it over with 0.06, which is this one here. And we have 0.0197. Okay, so 0.0197, but we're interested in the area that's greater than, so we're looking for the area that's greater than negative 2.506, or the probability that z is greater than negative 2.406, meaning that the area to the right. And as you already know that from our procedure table tells us that right equals to 1 minus the area from the table, which means we're going to take 1 minus 0.0197, and let's find out what we get. So 1 minus 0.0197, we get 0.9803. So 0.9803 in percent, meaning this is 98.03%, okay? So the probability that the senior owns at least $1,000 is 98.03%. Of course, I'm putting percent here, so it's easier for the interpretation. But when you key in your answer on ALEKS, please keep it in decimal form, unless you see the percent sign comes with the percent sign comes to the right of your answer key box, then your answer box, then you would do in percent, or else you always leave your answer in decimal. Okay, so how to do this on a graphing calculator? We do it greater than, right? So let's revisit what we have for our command. What do we have for our command for greater than? We do normal CDF x E99 mu sigma. All right. So what we have here, I created a practice problem for you with the same problem, but with the direction of using a graphing calculator. So we do normal CDF. You have x, there's only x value, one x value. And what you have here, next you're going to do E99. You have mu and sigma, which we apply to our problem where we do normal CDF. Our x value is 1,000. E99 Our mu value is 3,262. Sigma is 1,100. Close it, press enter. Okay. All right. So here it is, everybody. Same goes. Second bar. You go down to normal CDF and you're going to do your X value of 1,000, comma. You do second, comma, that gives you E99, comma again, 3,262, comma, and 1,100, close the parentheses. Now, I'm hoping to get something close to 0.98. Let's see if I have it. This is it, okay? So we have 0.980, 0.98012. So we're a teeny bit off. Earlier was 0.9803. So we underlined these digits here. We rounded to 4 decimal places and we ended up with this answer. Okay. So here we practice for the between, we practice for the greater than in terms of both the table and using a graphing calculator. I have so I have this practice problem for you here, and that would do it. It's possible that you get your assignment to be in terms of less than, greater than, or between. It's possible that you have the problem tell you to use the normal distribution table or by using a graphing calculator. So on your assignments, I will have a couple problems on using the table and a couple problems on using a graphing calculator. And that's all I have for you for section 6.2. So thank you for watching. And again, if you have any questions, please don't hesitate to reach out to me. I'm more than happy to help you.